So when we consider this question, you could find the mean is m hours, standard deviation denoted by sigma is 0.35, and it is given that 95% of times taken are longer than zero point 0.9 hours. So 95% are longer than 0.9 hours. So when we consider the random variable x has a normal distribution with mean m and variance 0.35 squared. And as per the question, probability of x greater than 0.9 hours is 95%. 95% can be written as 0.95. Okay, so when we standardize this one, we get probability of z greater than x minus. So what is z? Z is x minus mu divided by sigma, which is a random variable in normal distribution. So z greater than 0.9 minus m divided by sigma is 0.35, which is equal to 0.95. So here one of the important facts which we need to consider is about the curve, the normal distribution curve, and also the position of the point where it lies, right to the mean or left to the mean. Okay, so when we consider the curve, this is the mean value, and it is given that probability of x greater than 0.9 is 95%. So x greater than 0.9 is 95%. So when we consider, this would be the region which gives us the answer. That means the point, the value lies in the negative side. That means 0.9 minus m by 0.35 lies in the negative side. So in such cases, we assume 0.9 minus m by 0.35 as a negative answer. Let it be minus a. So this value becomes p of z greater than minus a is equal to 0.95, and as we know that probability of z greater than minus a is equal to phi of a. So we get phi of a is 0.95, or a is phi inverse of 0.95, which is equal to, so phi inverse 0.95 is 1.645 approximately. So we get the value of a as 1.645. Hence we can consider 0.9 minus m divided by 0.35 is equal to negative a, that is negative of 1.645. Now do simplify this one and get the value of m as 1.476. In the next part of the question, it's given that n is equal to 4, and as per the question, when we calculate probability of x less than 2, we get it as probability of z less than 2 minus mu by sigma, that is equal to P of z less than 2 minus 1.476 as we calculated in the part 1 divided by sigma as 0.35, which is equal to 0.9332 as answer. So probability of x less than 2 is 0.9332. And the next part of the question is probability of none of them take more than 2 hours. You know that probability of none of them take more than 2 hours is same as probability of all the cars take less than 2 hours. So probability of none of them take more than 2 hours is equivalent to probability of all of them take less than 2 hours. Yes, that can be calculated using 4C4 because we have totally 4 numbers and all the 4 takes less than 2 hours with a success of less than 2 hours, that is 0.9332, which we calculated in the previous question. Raised to 4 into 1 minus p. Remember the formula NCR p raised to r into 1 minus p raised to n minus r. So 1 minus p, which is 1 minus 0.9332, which is 0.0668 raised to 4 minus 4 is 0, which is equal to 0.9332 raised to 4, that is 0.758 as result. As per this question, given that mu is 3 sigma and probability of x is greater than 0.6 mu, we need to calculate mu and sigma square. Okay, so what can we do in this case? Is probability of x greater than 0.6 mu can be written as probability of z greater than 0.6 mu minus mu divided by sigma. Yes. Now probability of z greater than, either you can change mu in the form of 3 sigma or sigma in the form of mu. It's up to you. I'm changing all the mu's in the form of sigma. So we get it as 0.6 into 3 sigma minus this mu is 3 sigma all divided by sigma. That is P of z greater than 1.8 sigma minus 3 sigma divided by sigma. That is P of z greater than minus 1.2 sigma. 1.8 sigma minus 3 is minus 1.2 sigma all divided by sigma. Sigma and sigma get cancelled. So we get the answer as P of z greater than minus 1.2. P of z greater than minus 1.2 is same as phi of 1.2, and phi of 1.2 is 0.8849, which is round to 0.885 as 3 significant figures. Okay, It is another question. The time in minutes taken by Peter to walk to the shop and buy a newspaper is normally distributed with mean 9.5 and standard deviation 1.3. Find the probability that on a randomly chosen day, Peter takes longer than 10.2 minutes. So as per this question, the mean is mentioned as 9.5, that is mu is 9.5, and the standard deviation sigma is 1.3. Okay, we have to find the probability that on a randomly chosen day Peter takes longer than 10.2 minutes. So how do we calculate this question? So here, if we consider a random variable x, if x is a random variable which denotes the time taken by the Peter, okay, then x has a normal distribution with mean 9.5 and variance 1.3 squared. So as per the question, we want the Peter takes longer than 10.2 minutes. That means we want probability of x greater than 10.2, which is equal to, when we standardize it, we get probability of z greater than x minus mu by sigma, that is 10.2 minus mu 9.5 divided by sigma is 1.3, which is equal to P of z greater than 10.2 minus 9.5 divided by 1.3 is 0.538. As it is, probability of z greater than 0.538, which is equal to 1 minus 5 of 0.538, which is equal to 0.2954 as answer. So that is the answer for the first question. And the next part of the question is, on 90% of days he takes longer than t minutes. Find the value of t. So 90% of days he takes longer than t minutes. So I'll take another one board. So it's given that on 90% of days he takes longer than t minutes. That means probability of x is longer than t. So we need to calculate. So what's our question? Our question is to find the value of t. Okay. So p of x greater than t can be written as p of z greater than t minus mu. Mu is 9.5 divided by sigma is 1.3. That is 90%. 90%, if you make it as probability decimal, it is 0.9. Okay. Now let's consider the position. The position of t minus 9.5 by 1.3. Position of this variable in our graph. In the bell-shaped curve, P of z greater than t minus 9.5 by 1.3 is 0.9. It is 90%. That means when you look at this side, it comes to the left side of the mean. So this is the region represents t minus 9.5 by 1.3. And the value is negative here. So let's assume let t minus 9.5 divided by 1.3 be minus a. So our probability become P of z greater than negative a is equal to 0.9. It implies we know that P of z greater than minus a is same as phi of a. That is 0.9 or a is phi inverse 0.9, which is approximately 1.282. So the value of a is 1.282. Therefore, what happens to t minus 9.5 by 1.3? T minus 9.5 divided by 1.3 is minus a, that is minus 1.282. Just do the normal calculation. We get t is equal to, cross multiply it and added by 9.5, we get 7.8. The third part of the question is calculate an estimate of the number of days in a year on which Peter takes less than 8.8 minutes to walk to the shop and buy a newspaper. So it is comparatively a simple question. So we have to find the estimate number of days in which Peter takes less than 8.8 minutes to walk to the shop and buy a newspaper. Okay, and here it is not a leap year, it consists of only 365 days. So when we consider this part, let me take one more fresh page. So here we need to calculate P of random variable x less than 8.8, because we need to calculate probability of x less than 8.8. So when we convert x to the standard variable z, become P of z less than 8.8 minus mu as 9.5 divided by sigma, which is 1.3. So which is equal to P of z less than, when you calculate this, we get negative 0.538, which is 1 minus, as it is P of z less than negative a. You know P of z less than negative a is 1 minus phi of a. So it is 1 minus phi of 0.538. That is 1 minus the phi of 0.538 is 0.7046, which is equal to 0.2954. So that's the probability of x less than 8.8. Therefore, we can find the estimate number of days. Estimate number of days is total number, that is 365 days, multiplied by the probability, 0.2954, which is 107.821. So here approximately, if you choose 107 days or 108 days, any one of these answers would be acceptable. The heights of school desks have normal distribution with mean 69 cm and standard deviation sigma centimeter. It is known that 15.5% of these desks have height greater than 70 cm. The first part of the question is find the value of sigma. So when we look at this question, the mean is given as 69 centimeter and the standard deviation is sigma. So when we consider the random variable x is distributed normally with mean 69 and variance sigma squared. It is known that 15.5% of these desks have height greater than 70 centimeter. So it is known that the height greater than 70 centimeter is 15.5%. So greater than 70 centimeter can be written as P of x greater than 70, which is 15.5% as decimal 0.155. Okay, so when you standardize x to the variable z, we get z greater than 70 minus mu, x minus mu, 69 divided by sigma is 0.155. And when you look at the corresponding graph of this, probability of z greater than 70 minus 69 by sigma is 0.155. 0.155 or 15.5% comes to the right side of mu, so it is positive. So as it is positive, there won't be any change in the calculation. So when we continue the calculation, we get P of z greater than 70 minus 69 is 1 by sigma. 1 by sigma is equal to 0.155. Greater than 1 by sigma is equal to 0.155. And you know it is P of z greater than a. P of z greater than a is P of z greater than a is 1 minus phi of a. So we get it as 1 minus phi of 1 by sigma, which is equal to 0.155, or phi of 1 by sigma is equal to 1 minus 0.155, which is equal to 0.845, or 1 by sigma is equal to phi inverse 0.845, and phi inverse of 0.845 is 1.015. 1.015, or 1 by sigma is equal to 1.015, or sigma is equal to reciprocal of 1.015. that is equal to 0.985 as a result. So we get the standard deviation as 0.985. And when we go to the next part of the question, there it says, when Jodu sits at a desk, his knees are at a height of 58 centimeters above the floor. A desk is comfortable for Jodu if his knees are at least 9 centimeters below the top of the desk. And you know the mean height of the top of the desk is 69 centimeters. Okay, and the height of Jodu's knees is 58 centimeters above the floor. So when we consider the height here, we can get an idea that it is 58 plus 9, which is equal to 67 centimeters. A desk is comfortable for Jodu if his knees are at least 9 centimeters below the top of the desk. Jodu's school has 300 desks. Calculate an estimate of the number of desks that are comfortable for Jodu. So at present, Jodu's knees at 58 centimeters. If his height is at least 9 centimeters more, he will be more comfortable. At least 9 centimeters, that means what we can identify here is present height of the knees is 58 centimeters. If he is getting a height of minimum 9 more centimeters, that means if he gets a desk of at least 67 centimeters, he will be comfortable, or he will be comfortable if it is greater than 67 centimeters. So when we convert it into standardization, we get Z greater than 67 minus, already mu is 69, divided by sigma we calculated already as 0. What is sigma we calculated? 0.985. We calculated as 0.985. which is equal to probability of Z greater than, when we do this calculation we get minus 2.03. So it looks like probability of Z greater than negative A. You know that probability of Z greater than negative A is phi of A. So that's equal to phi of 2.03, which is equal to 0.9788. And now it's our turn to find the expected number of desks which are fit for Jodu. Therefore, expected number is, there are total 300 desks. Out of 300 desks, how many desks are suitable for Jodu with a probability of 0.9788? We get it as 300 into 0.9788 is 293.6. Approximately 293 desks are fit for Jodu.